Hi, in this video we will be making an AI car parking dashboard using which we will be able to see the number of cars that are parked in the parking lot. So let's start with knowing the components that we are using. The first thing for detecting the number of vehicles, that is the cars, is the ESP32 cam. And I have mounted this ESP32 cam using a mobile stand, and I have a smartphone on which we will be viewing the number of cars count details on it, so that will be acting as a dashboard, and then a computer for programming this ESP32 cam. So let's see the working now. So first of all, let's connect the ESP32 cam to the computer. So once we connect the ESP32 cam, we should be able to get the IP address and now in a few seconds we will be able to get the IP address, that is 192.168.1.13, that got displayed there, and that is the IP address using which we will be accessing this ESP32 cam web server for getting the details of the cars count. So let's see the working now. So here I have the smartphone ready with a web page on which I have typed 192.168.1.13 on the URL, and I click enter, and immediately it shows the number of cars that are being parked. It shows that 0 cars are parked. Let's start parking the cars and see the parking count. So I have the toy cars. You can use any kind of objects that you have, any kind of vehicles that you have, small toys that you have. So let me place one of the car here in the parking lot 1, and immediately it should show number of cars parked should be 1. And then let me bring another one and place it here at the second slot. Now it should show cars count is equal to 2. Okay, let me take away one of it. So it immediately showed 1, and again shows 0 cars. So if I place it only for 2, it shows 1 car count. So let's see how to achieve this project using ESP32 cam. So our next step is to make a machine learning project for our ESP32 cam in order to identify the car parking system and get the number of cars count. So for that, we will be using the online tool called Edge Impulse. So we have to use studio.edgeimpulse.com link for accessing this web page, on which you will be able to create a project for the ESP32. So let's start making the project. So you need to click on this create new project. So overall, you can create 4 projects at a time. So if you want to create another project, means you need to delete any one of the existing project, and only after that you will be able to create a new project. So let me open an already existing project for our cars detecting project so that I can explain you without wasting time. So let's say that you have clicked this create a new project, and it will show you this box for entering the project name. So you have entered the project name as cars_detection project, or whatever the name you want. So I will open this project cars detection that I've already done. So these are the sequence of steps that we need to follow for completing this project. So the project starts with the data acquisition. So data acquisition means you need to collect the data for detecting the cars. So let's do that. So I click on this data acquisition, right? So we will be using the mobile phone for collecting the data samples. So let's collect the data and get back to Edge Impulse project. So the next step of our Edge Impulse cars detection project is to capture the image samples. So to do that, under the option data acquisition, we have the block called collect data, under which the Edge Impulse provides a link, that is connect a device, under which we will be using the first option, that is scan QR code to connect your phone. So this QR code helps us to collect the image samples for our cars that is being parked in the lots. So I will take the mobile phone. I have opened the camera and I'm scanning this QR code that takes me to this link. It's a web URL of Edge Impulse, on which then I will be clicking on this collecting images and click this give access to camera, and here we go, we got the access to camera. So what happens here is that whenever you click this capture, immediately your captured image will be sent to your project on which you are working now. So let's see how it is being done. So now I will mount this mobile phone on this stand over here that focuses this parking lot. So now we have to teach the computer that the way the cars are parked, so that the computer can detect on which slot it has been parked and it can take the cars count. So let's see how to do that. So here, first let me place any car on slot number 1, and after that I need to click on this capture. So once I click on this capture, immediately that captured image is sent to the Edge Impulse project. So to view that, when you scroll down, you can see the captured image over here. Our next step is to make a label for it. So to make a label, I will just drag and drop like a box, and then I will name it as space 1. Right, so now let me do it for space 2. I'll keep another car over here for our understanding. Okay, so now I have placed another car in slot number 2. So I click capture. Immediately our captured image should get updated here. Yes, and now I need to make a label for it and name it as space 2. And click set label. So that's it. So likewise, I have made 30 samples for each, that is for space 2 and space 1. I have taken 30 samples each. So here, these are the collected image samples. So I have made labels for each of these cars. That is, for if I have placed the car in the slot number 2, I named the label as space 2. So that I have taken 30 samples for space 2. And here the space 1 starts after 30 samples of space 2. So since I have placed it in the slot number 1. I have named it as space number 1. So I've taken 30 samples for space 1 and 30 samples for space 2. So after doing this, our next step is to click on this create edge impulse. So you need to select the second box as image and the third one as object detection images, and leave the first section as it is and the last section as it is. So here the output future shows that there are two machine learning classes, that is space 1 and space 2, for the computer to recognize. So now I click save impulse. After that, we go to the next one, that is the image option. Here, when we scroll down, to make the process of scanning these car parking in a smoother way, you need to select this color depth to grayscale so that this project will run quickly on ESP32 cam. So I selected grayscale and select and click saving parameters. So that's it. After doing it, the computer generates a cluster in which it shows how the computer identifies the space 1 and space 2 in the form of dots. So the only thing you need to make sure that these dots doesn't overlap each other or stay close to each other, so that there will be a problem in the output. So the output will not be perfect. So after that, we go to the next option. Yeah, you need to click on this generate futures. So the computer will take some time. Yeah, so now we got the message called job completed success. So we can go to the next step, that is object detection. So in this object detection, we need to click on this save and train. So you can leave these parameters as it is and click save and train. So our computer completed the training successfully by giving a message, job completed success. And while we are doing this on your computer, see that the F1 score that you get is near to 100% or greater than 90%. So only then we can make sure that the output will be perfect while detecting your cars in slot 1 and slot 2. And for space 1, it has given a 100% score, and then for space 2, 100% score. So now we have completed the training. Now we have to, so after getting the score, it's now time to generate our Arduino code for using it in ESP32 CAM. For that, you need to click on this deployment, and then you have to select Arduino library in this deployment target, and then you need to select the TensorFlow Lite in this option. And here at the top, you need to select expressive ESP32 240 megahertz. And you can leave this as it is and click save. So that's it. You can click build now. So once we click build, a project code for Arduino IDE will be generated. that is a zip file. So you can install that zip file as a library on your Arduino code, on your Arduino IDE, and we can start making use of the project. So now we got a message that built Arduino library. So Edge Impulse has successfully created Arduino code for our ESP32. So here it also gives us the steps how to access this library and make use of the project. So on the Arduino IDE, after downloading the zip file, we can select the sketch include library and add the zip library. And then after adding the zip library, we can click this file examples cars detection project AI interfacing project, so that we will be able to run the project directly on the Arduino IDE. So I'll close this and let me see in the downloads. So here in the downloads, we can see that the zip file has been downloaded. So now we can go directly to the Arduino IDE and start installing this library. So now we are at the final part of our project, that is the programming part. Open the Arduino IDE. At the top menu of this Arduino IDE, we have this sketch, and then we need to click include library. And here you have that add zip library. So once we do that, you need to locate the downloads folder. That we downloaded from the Chrome browser from Edge Impulse. So this is the last downloaded zip file from the Edge Impulse. So I just click on that and click open. So once we do that, it will take 1 or 2 minutes for setting the zip file and importing all the program files on the Arduino IDE. After that, you will get a message that successfully installed the library from the zip folder. And after that, you can start making use of it. So after doing that, you need to open File, then Examples, and here are the libraries list that are being displayed, and under the title examples from custom libraries are the ones that you have imported by yourself. So under which we need to locate the zip file that we installed now. The zip file name is the project name, that is Cars Detection Project AI Interfacing. So this is what we want, and these are the different files that are being imported using that zip folder, right? So inside which we need to click this ESP32, and here we want this ESP32 camera. So I click on that, and it will take me to this project, that is ESP32 camera. Right, so here in the Edge Impulse, this project will give us the number of cars that are being parked, as well as at which point it is parked, and what is the label name that is being parked. So these are the details that we get from the view of the camera. But we need to make a certain changes, is that as we saw in our project, we had a mobile phone that displays the number of cars that are parked. So in order to do that, we made the ESP32 cam to become a web server, so that on the web server, we will be sending the details of the number of cars that are parked on it. So let's see how it is done. So when we scroll down and look at the Edge Impulse project, the line 193. Yes, so here we have a comment that is being done named as print the prediction. And this is the prediction that is being printed on the serial monitor for our reference. So here the prediction goes like, if there are no objects, if there are no cars parked, so this condition will be triggered. Else, if there are any object found, then it will count the number of cars, and the number of cars count is received using this result.bounding boxes count. And also, if you want to know the details of the car, you can get it by the name or at which X point and which Y point it is being present, and its width and height of the car details. So now our focus is to get the number of cars. So we will make use of this result.bounding boxes count so that we will be able to get the number of cars count. Okay, so now let's see how to display these details on the web page. To do that, let me open another project. Yeah, so here is the project. I've named it as Display Dynamic Text ESP32 CAM web server. This program enables the ESP32 CAM to become a web server and display a dynamic text on it. So this dynamic text will be of type string. So here I have mentioned this string as the dynamic string, and this is our point of focus. So let's see how this dynamic string is displayed instantly on the web page. So when you scroll down here in the loop, we update this dynamic string value to a counter number. I'm just making an integer counter to count itself and it to display the updated counter number on the web page. So I'm doing it by converting this counter value, that is the integer value, into a string, and I'm passing it to the dynamic string. So when we scroll up, so here is the function that makes this dynamic string to be sent on the web URL. So when I scroll up again, you need to look for handle get string. So this handle get string is called whenever this get string is sent along with the URL. So this get string is called inside the script function of the HTML page when this fetch ESP32 string function is called. So this fetch ESP32 function, ESP32 string function is called for every 2 seconds. So for every 2 seconds, that is the 2000 milliseconds, it will send this URL as a get string with a response. It will get that text, that is the dynamic string text, and it will update that string to the data variable. And this data variable is then updated inside this document.getElement by ID with a ID string display that is inside the HTML page. So this ID will get updated with the current counter value. So now we are applying this to our project. So here the counter was being updated regularly, but now we want the number of cars count. To do that, let me open the modified project. So let me open the modified project. So here is the combined project of the edge impulse code as well as the dynamic string web server code. So I just look for the void loop. Inside the void loop, I come down, and here we have that print the prediction. Here is where we are updating the value. So as I told you, if there are no objects found, then this condition, this if condition will be called, inside which we are updating this string, that is number of cars parked. Sorry, this is the integer value. So we are updating this integer value, that is cars parked. So when you go up, you can see it's being defined at the top over here. That is the integer value. So initially I'm setting it to 0, after which if there are no cars or no object found in the ESP32 camera, then we will make it 0. And we are updating the dynamic text to the integer converted into string and sending it by concatenating it with number of cars. Like if there are 0 cars, we'll say 0 space cars. And if there is any cars present, then it will display, we will make use of this cars park, and then we will get the details of number of count using this result.bounding box from here. I just copied this and put it here so that I get that number of counts, that is the integer value. And after that, I again convert that into a string and I update this in the dynamic string. And if there is one car, then it will say 1 space cars, else 2 space cars. So let's see the working now. I will turn on the camera and I will also open the serial monitor. And I will connect the ESP32 cam to the computer. Here we go. So we will get the IP address, that is 192.168.1.11. So let me open the web page and type the IP. Yeah, I have opened the web page and then I'm typing the IP address 22.168.1.11 and I click enter. Yeah, it shows us 0 parked. And let me come back to the project here. As you see, it displays this condition here, predictions DSP, and how many milliseconds, and classification and anomaly. So because there are no cars parked, let me open. So let me turn on the camera as well. Okay, now I have opened the camera and let me place the car in the point number 1. And now immediately in the serial monitor, we are getting the label is space 1, and also it displays at which point there is 0.87. At this point, there is 1 car, and also on our web page, it displays 1 car. So let me place another car over here. Okay, it shows 2 different numbers over here. As you see, 0.8 and 0.5. At 2 points, there are 2 cars, and also on the display of our web page, we are getting 2 cars up.